Greetings once again, welcome to another edition. In this session, we'll be looking at the November 2023 Mathematics Paper 1, more specifically question 2. So question 2 will be mostly based on the series, that is, our geometric series, arithmetic series, and quadratic series. So in the case of this paper, as you can see, our question 2 is based on the arithmetic series, and then the other part will be based on the quadratic series or a quadratic number pattern. So let us dive into question 2.1 and see what are we expected to do on 2.1.1. So if you look at the series which we are given 7 plus 12 plus 17 and so on. And we are told at the top there that this is an arithmetic series. And the question for 2.1.1 reads, determine the value of T91. So what they are asking us essentially is, what is the term when n is equal to 91? So essentially, what is term 91? That is the question which we are trying to answer. So for us to be able to answer that question, we need to remember our general expression, which will help us to find any term, which is always a plus n minus 1 times d, where our a is the first term and the d is the difference between consecutive terms. So if you look at our series, it should be easy for us to be able to find a and d. Then in turn, we'll be able to find term 91. So if you look carefully, we have 7 plus 12 plus 17. So what always comes here is our first term, which is always equal to a. So our a is 7. And then remember that the d is always the difference between the two consecutive terms. So meaning when I do 17 minus 12, if you look at what we should get, should be the same as when we do 12 minus 7. So if you look careful, when we do 12 minus 7, we'll get the same answer as when we do 17 minus 12. And that will give us an answer of 5. So if you now look carefully, we can now go and find our Tn. Then we will now replace the n with 91. So remember that it was a, n minus 1 times d. So our a is 7. Then n minus 1, our d is 5. So when we simplify and multiply here, we'll have 7 plus 5n minus 7. And this will end up giving us 5n plus 2 as our general expression of Tn. So now that we have the equation, we can now go ahead and find our T91, which is what we are looking for, which means wherever we see n, we are going to go and put 91, then put in plus 2. So let's quickly go to our calculator and see what we get. Okay, so we have 5 multiplied by 91 plus 2. And if you look at our answer, it becomes 457. That is T91. So now that we have T91, let's go to the second question, which is 2.1.2, where they are saying that what we should do is calculate S91. So what is S91? S91, all what it means is the sum of the first 91 terms. That is what S91 is. So how are we going to find the sum of the first 91 terms? What I need you to remember is the equation which we use to find the sum of n terms. And that equation is Sn equals n over 2 into 2a plus n minus 1 times d. This is the formula which we use to find the sum of n terms. So now we know that clearly, because we are looking for S91, that means our n is 91. But for this series, we already know that our a, which is the first term, is 7, and our d, we found, which was the difference between consecutive terms, is 5. So we are clearly in a position to use our formula to find the sum of the first 91 terms. So let's go ahead and put S91, and our n is 91, so I'll have 91 divided by 2. Then I'll have 2 times our a, which is 7, plus our n, which is 91, minus 1 times our d, which is 5. So let's take our calculator and find the answer for S91 and see what we are getting. So therefore, S91 will be, let's get our calculator. So there's our calculator. So let's punch in. So we have 91 divided by 2 into 2 times 7 plus 91 minus 1 multiplied by 5, and then we close the bracket. So if you look carefully, the answer we are going to get there is just that my calculator writes or likes writing things in scientific form. But if you look carefully, the answer is supposed to be 21, 1, 1, 2. That is the sum of our 91 terms. So that concludes question 2.1.2. So let's go to question 2.1.3. So for question 2.1.3, we are being asked to calculate the n for which the Tn will be equal to 517. So what you should remember is that previously we found Tn, which was, let's go and check, it was 5n plus 2. So we found our Tn as 5n plus 2. So if you look at the problem, they are telling us that, which is why I'm going to say we are given that Tn is equal to 517 now. So essentially, if we are given Tn, what we want to know is that what n value did we put in this equation for us to get that Tn there? That is the question. So which means we will go and put 517 and equate it to the Tn expression because it is Tn. So it will be 5n plus 2. Then what you should be doing, because we are trying to solve for n, so what we'll do there is we'll transpose, so that what you will have will simply be 517 minus 2 equals 5n. And if you look carefully, when you minus 2 there, you'll end up having 515 equals 5n. And remember that what we are trying to solve for is n. So that's why I should divide by 5 and divide by 5. And the 5 and that 5 will cancel. So let's quickly go to our calculator and do this division. So what I have is 515 divided by 5. So I'm getting 103. So this means that our n is 103. So make sure that you do understand what we did here. So the next question is question 2.2. So let's go and have a look at question 2.2 and what is expected. So let's have a look at question 2.2 and see what is expected of us. So the question reads, or the statement reads, the following information is given about a quadratic number pattern. So we're given that T1 is 3, T2 minus T1 is 9, and we are also given that difference. Then they further tell us that we are required to show that our T5 is going to be 111. So there's a couple of things which we need to remember before we proceed about a quadratic series or a quadratic pattern. One of the most important things which we need to remember is that the second difference is constant. In other words, it is the same. So meaning whenever we are working with a quadratic series or a quadratic pattern, it is the second difference which is always the same. And what we also need to remember is that the first term, in fact, let's not worry about the first term for now. So let's proceed and quickly use this one fact which we know. So if you look carefully, they gave us that T1 is equal to 3. Then they gave us that T1 or T2 minus T1 equals 9. What this then means is that our T2 is the same as 9 plus T1, which is the same as 9 plus 3, which means our T2 is 12. Then if you look carefully, we are given another expression, which is T3 minus T2 equals 21. So this means that our T3 is the same as 21 plus T2, of which this will be 21 plus 12, which will be 33. That is what we have. So now that we have these, we can now go ahead and quickly write them down. So the first term is 3, the second term is 12, the third term is 33. And the difference between these terms here, this will be 9. Then the difference between term 3 and term 2 is what is given already there, which is 21. And what we know is that the second difference is equal. So where is the second difference? It is this last layer here. What is going on there? That is the second difference. And if you look at the note, I said the second difference should be equal. So if you look carefully, we'll do 9 minus 12. 21 minus 9, which will be 12. So what we know is that when we take the difference between this term and the one which is supposed to be here, because it's the second difference, it is also supposed to be 12. So which means, how do we find this term here? That term there will simply be 29. If you look carefully, that term will simply be given by 21 plus 12, like that. That is how you will find that term which is there. And then there's another term there. So let me quickly squeeze this in. I'll put it below here and put in the actual number here. Okay, because when you minus 21, when you minus 33 and 21, you should get 12. So which then means that I can now find the next term that is sitting there, because the difference of this term and this term should give me that one there. So if you think carefully, that term which should be sitting there, so that when I subtract, I get this one here, 33. It means I need to have 66 sitting there. Okay, now let's go and have a look at the next one. So since I have 66, then here I know that the constant difference or the second difference should always be the same. So now I just need to do 33 plus 12, which will give us, it will give us 45 there. Okay, it's the same pattern. And then what I know is that the term that comes after 66, when I subtract 66, I should get 45. So essentially I need to add 66 to 45 so that what I will get there will be 1, 1, 1. So that is what we obtain. So if you look carefully, I have found the term which they are looking for because they were looking for term 5. So here I have term 1, term 2, term 3, term 4, and term number 5. So I should go and tell them that our term number 5, which is what we were looking for, is indeed 111. How did we find 111? You add 66 with 45. So that's how you find the next term. If for you to find 66, you add 33 with 33. For you to find what you call 33, you add 12 and 21. So that is how we went. And we're using the fact that we know that the second difference should be constant, as I made a note. So that there really helped us to be able to find term 5 by just knowing that fact. So with that said, now let's go and have a look at 2.2. So for 2.2.2, essentially they are saying we should show that the general term of the quadratic pattern is given by that. So how I would paraphrase this question is that we need to find Tn. What is Tn? So if you remember, generally, Tn is given by an squared plus bn plus c. So now the question just becomes, how do you find a, how do you find b, and how do you find c? So let me remind you of how do we find a, b, and c. So finding a should be easy. For a, how we are going to find it, 2a should always be equal to the second difference. So finding a should be very simple. So if you look at our second difference there, it is 12. So that means 2a is equal to 12. And when you divide here by 2 so that we solve for a, what you will see is that the a which we are going to get is 6. So we are getting a is 6. So let's go now and have a look at how do we find b. The equation which we will always use to find b is this one. It will be 3a plus b. That should always be equal to term 2 minus term 1. So if you go to the previous page, you should be able to see that t2 minus t1 is 9. So that we know, so that our t2 minus t1, that is 9. And we also have found our a to be 6. So if we plug back, you will see that we will have 3 times a, which is 6, plus b equals our t2 minus t1, which will be 9. So you'll see that we will have b plus 3 times 6, that will be 18, equals 9. So when we solve here, you will see that we will have 9 minus 18 equaling b. So 9 minus 18 is negative 9. So therefore our b, we have found it to be minus 9. So now let's have a look at the equation for finding c. So the equation which we will always use when we are looking for c is this one. So a plus b plus c is equal to term 1. That is the equation which we will always use for finding c. So our a we already have, which is 6, plus our b we have, it's negative 9, plus our c we do not have, then this should be equal to term 1. So if I quickly have a look at term 1, it was given as 3. So term 1 is 3, so which means that what we have is 6 minus 9, that will be negative 3 plus c, and this will be 3. So if I solve for c, you'll see that we'll have 3 plus 3 when I transpose. And the c value, which we will get, will simply be a 6. So that is our c. So we can therefore now write the equation Tn, which is what they were saying we should prove. So our Tn is now, we need our a, which is 6, so it is 6n squared. Our b, remember we find minus 9, so it is minus 9n, plus our c is 6. So if you look at this equation and what they were saying we should show, they are the same. 6n squared minus 9n plus 6, 6n squared minus 9n plus 6. That is what they were expecting us to be able to do. So now let's go ahead and do the very last question, which is question 2.2.3. So make sure that these equations you do note down because they are very important. The equation for finding b, the equation for finding c, and also the equation for finding a. These are very important when you are dealing with your quadratic series. So there's many ways to go about doing the last question, which is question 2.2.3. So they're saying we should show that it is increasing for all n is an element of natural numbers. So let's write our Tn, which is 6n squared minus 9n, and then plus, let me just check, plus 6. So if you remember, how do we see when a function is increasing? What you should know by now is that an increasing function, what it has is a positive gradient. So once a function is a positive gradient, then we know that it is increasing. And when you are given a function, how do you find the gradient? What you should remember is that the derivative of a function the derivative of a function, what it is equal to, it gives you the gradient of the tangent, the gradient of the tangent to the function at any point n. So what this means is that we can easily go and find the gradient of this function by simply finding the derivative of this function. So if you find the derivative, you should see that the n squared there will drop the 2, which will multiply with the 6, which will give us 12n. And then when we derive 9n, we will get 9. And what we want the gradient to be greater than 0. So we want the gradient to be positive because we want to check for what n values is the function having a positive gradient, meaning it is increasing. So if you look carefully, what we have is just 12n minus 9 greater than 0. So if you look carefully, if you transpose, you'll have 12n greater than 9. And then what you can do is simply divide by 12 because remember, we are interested in n. So when you divide, you will find n as 9 over 12, which will simply be n. When you factor out the 3, it will just be 3 over 4. So what does these results, or what does this answer mean? What the answer means is that for any n value which is greater than 3 over 4, the gradient is positive. And what a positive gradient means, as we said previously, is that the function is increasing. So a positive gradient means an increasing function. So as you can see, any value which is greater than 3 over 4 will result in a positive gradient. But if you look at our question, it is saying as long as n is an element of natural numbers, then that pattern will increase. And this is true. So we've shown that because natural numbers, remember that we'll start from, we'll have 1, 2, 3, 4, and so on until we reach whatever number which we want. So clearly we can see that all these numbers, all these n's, they are greater than 3 over 4. So that is why this here, that statement is true, that our pattern will be increasing for all n is an element of natural numbers. So I hope this makes sense and it helps. Just make sure that you practice again and again and again. I hope this session helps.